Well, I think the cost is actually not going to be crazy high, like less than a car.
Elon Musk has promised to help the elderly escape the burden of expensive and impractical caregiving solutions. With a projected price under $20,000, Tesla Bot isn't just cost-effective. It's a powerful assistant that helps seniors live more safely and independently every day. So, what criteria must Tesla Optimus meet to truly fulfill its mission? Before we begin, please help us reach 8,500 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Model Q, Tesla EVs, and the latest news. How does Optimus achieve durability over 20 years? Tesla Optimus is not just an intelligent machine, it's a clear embodiment of Elon Musk's long-term and sustainable product vision. While most current robots are designed to operate reliably for just 5 to 10 years, Tesla has set an ambitious goal. Optimus should function continuously for 15 to 20 years without needing a major overhaul. To achieve this, every element in Optimus's design has been meticulously engineered, from materials and battery systems to artificial intelligence and durability testing. First is the robot's skeletal frame, where Tesla uses 7075-T6 aluminum alloy, a material commonly used in aerospace due to its exceptional strength-to-weight ratio. This alloy has a tensile strength of up to 83,000 pounds per square inch, significantly higher than the materials typically found in commercial robots. In addition, high-stress areas such as the shoulders, knees, and torso are reinforced with carbon fiber reinforced plastic CFRP, a material that is both lightweight and highly impact resistant. In contrast, while robots like Boston Dynamics Atlas also use titanium and aluminum, the heavier weight of titanium reduces their speed and agility during movement and task execution. Beyond the frame, all moving parts including joints, gears, and motors are designed for longevity. Tesla employs stainless steel bearings, high-grade synthetic lubricants for gearboxes, and motors with excellent thermal management to ensure long-term reliability. Each joint undergoes lab testing with over 1 million flex cycles, simulating more than a decade of real-world operation. This enables Optimus to maintain precision and stability whether it's working in a dusty factory or performing everyday household tasks. One of the key components contributing to Optimus's long lifespan is its 4680 battery system, developed in-house by Tesla. This new lithium-ion cell type features higher energy density, greater power output, and a significantly longer life cycle than previous generations. Internal testing shows these cells can retain over 80% of their capacity after 3,000 charge-discharge cycles, equivalent to more than 15 years of daily use. The battery management software includes smart charging algorithms to minimize heat and slow degradation over time. As a result, Optimus can operate for 8 to 12 hours a day without significant battery wear, greatly reducing replacement costs. Durability goes beyond just the physical. Optimus is also built to last intellectually, leveraging Tesla's deep learning AI platform originally developed for autonomous vehicles. The robot can learn on its own, adapt its behavior, and even protect itself from mechanical damage. For instance, if it detects unusual force in a joint, the control system will automatically reduce usage of that joint and redistribute the workload to other parts. This allows the robot to operate more intelligently over time while reducing component wear. Remarkably, Optimus doesn't require frequent maintenance trips. Every internal component from motors to sensors is designed in a modular fashion, allowing for easy replacement without disassembling the entire robot. Its cooling system combines passive heat dissipation with active airflow fans, ensuring stable performance over extended hours without overheating. Even critical sensors like cameras, force sensors, and positioning modules come with backups so that the robot can keep functioning even if one component fails. Tesla has also heavily invested in durability testing. In the lab, Optimus is subjected to extreme temperature ranges, from negative 20 degrees Celsius to over 45 degrees Celsius, constant vibration, and drop tests from 1 meter to assess impact resistance. Additionally, advanced digital simulations are used to predict stress points in the robot's structure after thousands of operating hours. This allows Tesla to fine-tune the design early on rather than waiting for failures in the field. And if anyone still doubts Tesla's ability to build long-lasting products, just look at the original Tesla Roadsters. More than 15 years later, many of those first-generation vehicles are still on the road with their original batteries and drive systems intact. Tesla has already proven that its products are not only beautifully designed, but also built to endure. Now, with Optimus, that same philosophy is being extended into the world of robotics. Every design choice, from materials and batteries to software architecture and assembly techniques, serves one unified goal: to enable Optimus to perform reliably for at least 20 years. In an era marked by labor shortages and rising demand for automation, a robot that can learn, conserve energy, avoid breakdowns, and work for decades like Optimus is poised to become an indispensable asset to both businesses and individual users. Once again, please help us reach 8,200 subscribers. This is important for us to stay motivated. Thank you. What level of self-control does Optimus have? The autonomy of Tesla. Optimus is no longer a vague concept or a futuristic dream. It is rapidly becoming a clear reality thanks to technological advancements and concrete results from real-world testing. Elon Musk has declared that this humanoid robot is on track to achieve full autonomy by 2025, a milestone no other company in the world has yet reached in the field of humanoid robotics. What fundamentally sets Optimus apart from traditional robots is its ability to learn and respond to unscripted situations. Instead of following pre-programmed sequences, Optimus can analyze its environment, react, and make decisions based on data collected from its sensors combined with deep learning AI. This capability has already been demonstrated through tests in which Optimus correctly responded to unexpected scenarios, such as picking up a dropped object, reacting to sudden verbal commands from a human, or avoiding obstacles in a living space. At the We Robot 2025 event, Tesla showcased a family simulation scenario where Optimus detected a child about to slip and immediately reached out to catch them with a response delay of under 300 milliseconds, equivalent to human reflex speed. Such actions cannot be pre-coded. They require real-time analysis and instant response, which is the essence of true autonomy. Another major breakthrough bringing Optimus closer to full self-operation is its next-generation hand system, featuring 22 degrees of freedom, allowing each finger to move independently like a human hand. This marks a significant improvement over many existing robots, which typically have only 5 to 10 degrees of freedom and cannot perform complex tasks. With this design, Optimus can execute high-precision tasks such as catching a tennis ball traveling at 80 to 100 kilometers per hour or assembling tiny components like 0.8mm screws, common in watchmaking and high-end electronics. In an internal test, Tesla had Optimus assemble the outer shell of an Apple Watch in just 3 minutes with flawless accuracy and 0 errors. A critical factor in achieving true autonomy for robots is the ability to communicate effectively with humans. Tesla has integrated software into Optimus that builds on the same platform as the full self-driving FSD technology, proven through billions of real-world miles. As a result, Optimus not only understands voice commands, but can also comprehend conversational context, respond naturally, and adjust its gestures and body language to fit the situation. In tests conducted at the Fremont factory, Optimus was able to reply to users within 2 to 3 seconds, even modifying its tone of voice and head or hand movements to express appropriate emotions. Equipped with over 20 vision and tactile sensors across its body, the robot can recognize facial expressions and emotional states such as happiness, sadness, or stress by analyzing facial cues and vocal tone, then choose suitable responses. This is a key requirement to ensure the robot can operate safely and empathetically in environments like homes or hospitals, where nuanced human interaction is essential. Tesla's ultimate goal with Optimus is to reach a level of complete, unsupervised automation. Elon Musk once stated, "Optimus will become the most productive worker in the world without the need for supervision." In the second quarter of 2025, a team of 5 Optimus robots was trialed in round-the-clock operation at Tesla's factories in Texas and California. These robots performed parts sorting and assembled control modules for electric vehicles continuously for 4 weeks, without a single technical error, achieving 100% accuracy across more than 1,200 task cycles. Tesla also revealed that more than 50% of its robotics R&D resources are focused solely on the Optimus hand, with over 300 engineers specializing in mechatronics, control systems, and tactile sensing. This level of investment reflects the company's serious commitment to making Optimus a core workforce in both industrial and personal domains. The combination of deep learning AI, precision mechanical design, and a new generation sensor network is transforming Tesla Optimus into a symbol of high-level automation. It is no longer just a supporting device. It is becoming an intelligent partner capable of learning, adapting, and responding dynamically to the world around it. The concept of autonomy is no longer limited to self-driving cars. It is expanding into the realm of humanoid robots with unprecedented capabilities. At the current pace of development, the prospect of every household, factory, or even space station having its own Tesla Optimus is closer than ever before. What makes Optimus Gen 3 an ideal home assistant? If many people used to doubt the mobility of humanoid robots, Tesla's recent update video has likely changed some minds. In a clip filmed right after the We the Robots event, multiple Optimus robots appear in real-world environments, freely walking among crowds and interacting with their surroundings, all without human control. What's astonishing is that Optimus Gen 2 can now walk at speeds of up to 4 miles per hour, only slightly slower than the average human walking speed. With feet similar in size to real humans, about 10 to 12 inches long and 4 to 5 inches wide, and highly flexible ankle joints, Optimus maintains balance on flat surfaces and can even climb stairs smoothly. All of this signals growing confidence in its mobility, a critical factor if Optimus is to truly become a helpful companion in the home. But Tesla didn't stop at just walking. Optimus Gen 3 marks a major leap forward in full autonomous operation. Tesla has designed a new charging system specifically for the robot, completely different from EV charging stations. When battery levels drop to 15%, the LED light on Optimus's head turns red, and the robot autonomously locates and connects to a charging dock without human intervention. Cameras and sensors help it precisely identify the charging port on its back, a rather unusual yet practical design that avoids interference with its arms and legs during charging. Once fully recharged, the light turns green, and the robot resumes work seamlessly. This is like a power nap that cools the motors, boosts efficiency, protects the battery, and extends its lifespan. For a busy household, having a robot that recharges itself after each shift without disturbing anyone is a huge plus. The learning and adaptation abilities of Optimus Gen 3 have also led many experts to acknowledge that Tesla is ahead of the pack. Optimus not only learns from humans, but it can also share data and experiences with other robots, like family members texting each other life hacks. This means that if one robot figures out a better way to mop the floor, others can immediately apply it, even in completely different homes. This is the true power of swarm intelligence, a kind of shared learning network similar to the collective learning in Tesla's self-driving cars, now applied to housework. As a result, Optimus doesn't just perform tasks well, he gets better at them over time. In reality, Optimus Gen 3 is already smart and agile enough to handle basic household chores such as cleaning, sorting laundry, folding clothes, or delivering items to charge.
If Optimus can watch videos, YouTube videos or how-to videos or whatever, and based on that video, just like a human can, learn how to do that thing, then you really have task extensibility that is dramatic, because then it can learn anything very quickly.
It may sound like science fiction, but this is the real capability of Tesla Bot Gen 3. A robot that can teach itself up to 100 new tasks per day simply by watching YouTube. No longer limited to pre-programmed actions, Optimus is moving toward the ability to adapt and develop skills at a pace that surpasses human learning. What makes a machine capable of learning that fast? Before we begin, please help us reach 8,200 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Model Q, Tesla EVs, and the latest news. What makes Tesla Bot Gen 3's ability to learn from video uniquely different? Tesla Bot Optimus is entering a remarkable evolutionary phase, not only through hardware, but now through real intelligence, the ability to learn like a human. In the latest videos shared on X, Optimus demonstrates agile movements and the ability to maintain balance on uneven terrain, a striking leap from the earlier clumsy version that once tripped over its own feet. What has caused such a rapid transformation? The answer lies in an advanced learning strategy Tesla calls sim-to-real reinforcement learning. Milan Kovac, a member of the Optimus AI team, explains that all movements are trained entirely in a simulated environment before being transferred to the real robot. This is the core advancement that allows Optimus not just to imitate, but to respond like a living being. More importantly, Tesla no longer needs cables or direct control. The robot can now learn to get up after falling, react to changing terrain in real time, and handle tasks solely through visual sensors. The key point is, Optimus is learning in the same way humans do through observation. Elon Musk once said, "Optimus can watch YouTube and learn to work like a human." Tesla has combined video-based learning with a visual model trained on millions of simulation data points, enabling Optimus to perform up to 100 new tasks within a few weeks, a feat that previously took months with manual programming. Modeling learning through vision learning to walk, fall, get up, and even move according to velocity commands means the robot is no longer confined to pre-coded behaviors. This is why Tesla completely skips LiDAR systems and instead relies entirely on vision sensors, just as they do when training FSD for vehicles. Just as humans don't need a detailed 3D map to move through the real world, Tesla Bot is learning to respond using only images and real-world experience. With its brain powered by the FSD computer and a neural network shared with self-driving cars, Optimus is not merely a machine, it's a dynamic learning system capable of adapting, evolving, and expanding its skills over time. This not only allows for rapid learning but significantly reduces the cost of robot training and programming in the future. The flexible dance moves performed by Optimus are not just technical displays. They are proof that a machine can now learn about the world as we do through vision, trial and error, and self-improvement after each mistake. And the biggest question now is no longer, can robots learn like humans? But rather, what will Tesla Bot learn next and how fast? Once you understand how Optimus learns collaboratively, you'll realize that this is not just a robot. It is part of an intelligent ecosystem, evolving at an astonishing pace. Instead of training each robot individually, Tesla is building a system where knowledge is digitized, stored, and instantly shared across an entire army of robots. That's why you can train one Optimus in a kitchen in Texas, and, on the same day, another robot in a Berlin factory can assemble a part of the Cybertruck without having been directly instructed. This system goes far beyond the concept of conventional deep learning. It is distributed deep learning, where each unit acts as both student and teacher. It opens a new era of AI training. No more constraints of manual programming time. No more need for millions of lines of code just to teach a robot how to open a door or pick up trash. Instead, every behavior, from simple to complex, can be standardized, replicated, and scaled within seconds. A global network of robots is gradually becoming a living data repository, a collective AI organism learning in real time. And thanks to a unified AI software that powers the entire system, Tesla maintains near-perfect synchronization among all robots, ensuring that every skill update is deployed uniformly. This guarantees not only efficiency, but also paves the way for more flexible coordination strategies. Suppose one day Optimus is widely deployed in hospitals, logistics centers, or disaster zones. Tesla can instantly update first aid skills, transport procedures, or special scenarios with just a single training session. Notably, it is the combination of in-house developed hardware, high-efficiency electric motors, high-density batteries, lightweight frames designed by Tesla, with unconventional learning software that has led to this leap. Unlike rigid robots still being developed in research labs, Optimus is built to evolve through data. As a result, Its rate of improvement is non-linear. The more robots there are, the faster the system learns. Imagine if today Optimus knows 100 tasks, then after just 1 week with 1,000 robots operating, it could acquire more than 7,000 different skills. In 1 month, that number could exceed 200,000 skills, forming a living intelligence library no human could ever match. This makes the deployment of Optimus in fields like manufacturing, elderly care, cleaning, cooking, or small home repairs no longer a distant vision. Interestingly, Elon Musk has also emphasized that everything Tesla learned from electric vehicles such as drivetrain systems, battery management, lightweight structural design, and automated production processes has been directly integrated into Optimus. Here lies the crux. No other company has the same combination of real-world data, large-scale manufacturing capability, and real-world AI platform like Tesla. Traditional robotics companies remain stuck in small-scale test models, relying on engineers to manually code every movement or control them remotely. Meanwhile, Tesla has moved on to mass training via video, simulation, and instant deployment. From an economic perspective, this is a massive lever. Every time a new skill is learned, the training cost is distributed across the entire robot fleet. If it costs $10,000 to teach one robot to cook eggs, but 10,000 robots learn it, the training cost per robot drops to just $1. That means the more robots in operation, the smarter the system becomes. So when you see a simple video of Optimus picking up trash or using a microwave, don't just think of it as a cute demo. It's a manifestation of an expanding automated learning platform, a model in which every single action contributes to building a distributed superintelligence. And while many companies are still trying to build a robot that can simply walk steadily, Tesla has already created an army of robots that can learn, share, and adapt in real time. Optimus is not just the future of automation, it is the beginning of a world where AI is not only intelligent, but can learn and grow with you right inside your own home. And when the Optimus army reaches the scale of millions of units, we will no longer distinguish between service robots and intelligent companions, because that boundary will have already been erased. Once again, please help us reach 8,200 subscribers. This is important for us to stay motivated. Thank you. How does Tesla Bot's ability to learn create value? Unlike human workers who require years of training and often struggle with consistency, Tesla Bot Gen 3, known as Optimus, is designed to learn rapidly from video. In fact, it wouldn't be an exaggeration to say that Optimus could master up to 100 new tasks in a single day. That doesn't mean it will be cooking 100 different dishes, which would be an extremely complex challenge even for humans. Instead, Optimus is expected to absorb a wide range of simple yet essential tasks: wiping tables, cleaning floors, organizing items, and executing repetitive routines across domestic and industrial settings. This extraordinary learning speed is fueled by a centralized training system. Unlike human workers whose abilities vary widely, every Optimus unit shares the same neural core and continuously syncs with an evolving dataset. If one robot learns a task, that knowledge can be instantly distributed to all other units. That's a massive breakthrough in scalability and efficiency. Tesla's decision to enable Optimus to learn through video adds another revolutionary layer. By watching pre-recorded footage of a task, such as folding clothes, moving objects, or assembling parts, Optimus can replicate the actions using computer vision and spatial modeling. However, this strength also opens up a significant vulnerability. What if the robot learns from dangerous content? Concerns are rising about the potential for misuse. Imagine a scenario where Optimus is exposed to videos demonstrating harmful behaviors like weapon handling, sabotage, or illegal activities. Given its ability to replicate actions with high precision, this raises a legitimate fear that the robot could become more than just a tool, it could become a threat. Tesla is likely well aware of these risks. To address them, several AI safeguards should be implemented. First, Tesla must deploy advanced AI filters that screen all input videos based on contextual cues, keywords, and visual data. Any video containing suspicious terms like weapon, attack, or explosive should be blocked before training. Second, Optimus should only be allowed to learn from verified sources, Tesla's own training library, official YouTube channels, and curated user-generated content that has passed through human review. These preventive layers will ensure that Optimus remains a safe and controlled tool, not a potential liability. From a business perspective, the implications are massive. With the ability to work 8+ hours a day on just a 2.3 kilowatt-hour battery, Optimus is both energy efficient and persistent. Energy use, of course, will vary by task. Heavy lifting or fast-paced movements consume more power, while sorting, cleaning, or basic support duties require far less. Regardless, this gives Optimus a full shift of productivity without breaks, fatigue, or declining performance. This kind of consistency translates directly into profit. In the restaurant industry, for example, Optimus could perform waitstaff duties, help with dishwashing, and suggest meals tailored to individual preferences, all with perfect memory and a pixel-perfect digital smile. A restaurant that once needed 20 staff might now operate with 5 to 10, dramatically reducing labor costs while enhancing customer service. And thanks to its multitasking abilities, one Optimus can replace multiple human roles, quickly justifying its initial cost within just a few years. In manufacturing, where time equals money and delays can result in millions in losses, Optimus becomes even more vital. It can handle part assembly, quality control, material transport, and even adapt to new layouts, unlike traditional automation systems that are fixed and inflexible. Optimus introduces a new level of mobility and intelligence, which means fewer errors, faster turnarounds, and increased uptime. Some estimates suggest factories could see a 20 to 30% productivity boost simply by integrating Tesla bots into their workflow. Moreover, when paired with AI analytics, Optimus can help forecast demand, optimize inventory, and even recommend process improvements in real time. This transforms the robot from a labor-saving device into a strategic asset, one that gives businesses a powerful edge in increasingly competitive markets. And this is just the beginning. Optimus could unlock entire business models. In retail, it could become an AI-powered sales assistant. In agriculture, it could help plant and harvest crops. In personal services, it could act as a home assistant for cleaning, cooking, and even elder care. These aren't speculative ideas. They're viable use cases that reduce operational expenses and open new revenue streams. Startups could build entire businesses around renting out Tesla bots by the hour to homes and small businesses. With growing demand for automation and a price point expected to be within reach, this could turn into a multi-billion-dollar opportunity. That said, full commercial deployment is still about a year away. Tesla is targeting a public release by Q3 2026. Initially, production volume will likely be limited, but even a small-scale launch would represent a technological milestone. Humanoid robots are among the hardest challenges in tech, requiring perfect integration of hardware, software, and AI. Tesla still has work to do before Optimus becomes fully reliable for mainstream deployment. Current engineering efforts focus on improving Optimus's ability to operate in unpredictable environments and execute delicate tasks in close coordination with humans. One area where Tesla still needs to build trust is transparency. Many demo videos show Optimus moving quickly and efficiently, but with footage that has been sped up 2 times. That creates skepticism. Tesla must now begin demonstrating Optimus executing real-world tasks at real-world speeds, with no video edits or time-lapse tricks. Only then will the public truly believe in the readiness and capability of the Tesla bot. This paves the way for new business models, such as renting robots by the hour to households and small businesses. If Tesla stays on schedule, 2026 could mark a turning point when humanoid robots are finally deployed at scale across manufacturing, services, and daily life. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.